Hello students, my name is Professor Sonia Bajaj. I am Assistant Professor from Computer Science and Engineering Department at GH Raisoni University, Saikheda. I am proud member of E-Yantra team. Our university has complete E-Yantra lab setup at our premises. This lab setup aims at creating future generation embedded system engineers who are capable of providing practical solutions to the real world problems. Here in this video lecture series, we are going to capture all the basic components about the major equipment which is used in this E-Yantra lab setup. The major equipment which is used in this robotic research platform is the Firebird V bot. This is the major component which is used in almost every E-Yantra lab setup. As you can see, it is a comprehensive bot which has a modular architecture that is capable of interfacing various external hardware devices to it. This Firebird V bot is totally divided into 6 modules. The first module is power management module, then comes the sensing module, third one is the communication module, then the locomotion module, peripheral module, and the last one is the intelligence module. When we talk about intelligence module, basically we are talking about the microcontrollers that are embedded into this bot. As you can see here, this upper green plate is the ATmega 2560 microcontroller, whereas the lower plate is the ATmega 8 microcontroller. So here the ATmega 2560 acts as the master microcontroller and the ATmega 8 acts as the slave microcontroller. Coming on to the sensing module of this Firebird V bot, if I just turn this bot, you could see that there are white line sensors onto this bot. Again, if you see here, then there are infrared sensing sensors in each direction of this bot. Coming on to the communication module of this bot, the bot could communicate with the PC via 2 modes of communication. The first one is the USB slot. This is the USB slot through which the PC could communicate with this bot, whereas the another slot is for RS-232C cable through which our PC can again interact with this bot. Coming on to the locomotion module of this Firebird V bot, as we do not have any steering mechanism externally connected to this bot, therefore there is a grouping of caster wheel and these 2 wheels in collaboration which are used as locomotion module of this bot. These 2 wheels work on the principle of opposite locomotion. They also have priority encoders embedded into these wheels. If you could clearly see here, there is a black thing which is called as priority encoders, or in other words you can say these are the positioning encoders which are used to position these wheels in a particular direction. Coming on to the power management module of this Firebird V bot, the power management of this Firebird V bot is divided into basically 2 types. One is battery power mode, another is auxiliary power mode. Here is a switch provided through which this bot could be operated either in auxiliary power mode or in battery power mode. One has to take care that when a person is using this bot in battery power mode, then this switch has to be turned on to the battery mode. There is a nickel magnesium battery which is provided at the back of the bot, and a slot is there through which we can connect this battery to the bot. One should also take care that if this bot is used in auxiliary power mode, then this switch needs to be turned on to the auxiliary mode. One has to take precaution while operating this Firebird V bot in a particular mode to avoid any hazardous situations. As you can see, this Firebird V bot has various screws embedded onto it. These screws are capable of providing any external hardware interfacing to this bot. This bot itself is so comprehensive that any external tool could be embedded onto this bot with the help of these screw spaces provided. Apart from the modules that we have discussed now, there are few other components which need to be put light on. The first one is LCD panel. This LCD panel is used to display any message for a particular intended applications. Here you can see 2 buttons. These buttons, one button is the reset button and another is the boot button. Both these buttons are useful when we program this particular bot with the PC. The further section involves the discussion of various other components in brief, and it would be carried forward by Bharati Sayankar ma'am. Thank you.
Hello student, I am Dr. Bharati Sayankar, Dean School of Engineering, Raisoni University, Saikheda. I hope you will understand the introductory portion which is already taken by Professor Sonia Bajaj. Now I will elaborate about the sensors which are mounted on Firebird 5 platform. Starting with sharp IR range sensor, in which transmitter is IR ray and receiver is CCD array. Total 5 numbers of sensors are mounted on Firebird 5 platform. Second sensor is IR proximity sensor, transmitter is IR ray and receiver is photo transistor. Total 8 number of IR proximity sensors are mounted on Firebird platform. Third is white line sensor, in which transmitter is red light emitting diode and receiver is photo transistor. Total 1 number of white sensors are mounted on the Firebird platform. Fourth is position encoder, in which transmitter is IR transmitter and receiver is photo transistor. 2 number of position encoders are mounted on Firebird 5 platform. Fifth is infrared TSOP receiver, in which receiver is photo transistor and TSOP 1738, 1 number of infrared TSOP receiver is mounted on the Firebird platform. Sixth is servo mounted sensor pod. Purpose: mount a camera or sensor, and we can additionally add on the Firebird as per our requirement. Next is accelerometer. Accelerometer is used for measuring acceleration in particular direction. We can attach, add more number of accelerometer or requirement. Next is gyroscope. Gyroscope is a device used for providing stability and maintain fixed orientation. Ninth is ultrasonic sensor. Ultrasonic sensor is used for object detection. Count of Firebird is optional and we can add as per our requirement on the Firebird. Next is motion sensor. PIR motion sensor is used for detecting motion of the live object. Global positioning system GPS. GPS module are the devices which receive GPS signal to locate itself on earth. GPS module gives latitude and longitude information and we can add on as per our requirement on the Firebird 5 platform. Actuators: 260 RPM DC rated motors and servo motors are mounted on Firebird 5 platform. Next portion, that is the motor section, can be taken by Dr. Padmanabh Gadge.
Hello students, my name is Dr. Padmanabh Gadge, Professor at Mechanical Engineering Department, PhD Cell in Charge at Raisoni University, Saikheda, MP. Today's topic of discussion is the motion control of the motor in Firebird 5. The basic movement of the robot is involve motion of the robot and understanding the L293D IC, which involves number of parameters. Motion of the robots involve forward, backward, reverse, soft left, soft right and etc. And understanding the L293D IC, it gives the interconnection between the robot and the motor to control the action. The number of components others are motor interference of the Firebird, that is pin connection, logical table and writing C code. The various motion of the robot by which the robot run autonomously in the system can be clarified as forward motion, left motion, backward motion and right motion. In the forward motion, the two wheels of the robot moves in the forward direction. In the backward motion, the 2 wheels of the robot moves in a reverse direction. In the left movement, the right wheel moves in the forward direction and the left wheel move in the reverse direction, by which the position of the robot will be at the same position. And in the right turn, the left movement will be in a reverse direction and the right move is in a forward direction. The other movements are soft left and soft right, where the right leg in the soft right, the right leg moves in a forward direction and left wheel will be on the same position. In a soft left in a soft left movement, the left leg will move in a forward direction and the right will move in a same position. Backward left, where the left move in a backward direction, and backward right, the right move in a backward direction. This is the movement of the robot to the situation or the command given in a zeros and ones. The movement of the movement can be controlled by the direction control of the DC motor. The DC motor moves in a two direction, anti-clockwise direction and clockwise direction. When you want an anti-clockwise motion in the wheel, we give a positive terminal to the upper end of the motor, so that the anti-clockwise movement can be achieved. When we want an anti-clockwise clockwise movement, then we connect the negative terminal of the motion to upper end of the motor, by which we can get the clockwise movement in the motor. By this motion, by this calculating this motion, we achieve the number of movement like forward, backward, reverse, and soft left, soft right, and other things. These are connected to a pin. That pin is the L293D IC. That IC gives all the commands to the system by which the motor and the interference between the robot get connected. The pin 1, this is 60 pin IC, it gets a 600 milliampere supply, and the total movement of that IC and working of the IC is given in the figure. You can see the figure from 1 to 16. You will get motor in, motor out, ground, and other parameters. Now, if we want to see a pin connection and direction control in connection with the port, you can see P10 is a left motor control, PA1 is a left motor control, and PA2 is a right motor control, PA3 is a right motor control, where two pin for enabling the motor drive IC is connected to the port L, where PL3 is a left channel enable and PL4 is a right channel enable. The coding is done in such a way that the forward, backward, left, right, soft, right, and stop motion can be achieved, where the higher node connection like LF and RF given 1 1 when we want to go in a forward direction, where when the LB and RB given higher connection like 1 1, then it goes in a reverse direction. When you want to stop the motor, all the coding will be 0. This pin connection can be achieved in a particular format. That format has been shown to you in the figure. Now, there is a program for running this IC in a proper sense. This program is coded in C language, and that include number of things, that include hash, a VR file, include hash, interrupt file, include hash delay file. The program detail has been covered, will be covered in the next lecture, upcoming lecture of our tutorial. Thank you.